Okay, hello everyone. How are we doing? It has been a while, pretty long while, I think, since we did a live stream. A lot of things have happened, which is super interesting, like the things that happened. So essentially last month, I spent most of the month in San Francisco, and San Francisco is kind of like a mecca of AI at the moment. There's a lot of kind of energy and lots of people that are really working on building stuff, and it's kind of amazing. And yeah, I've been I attended a few hackathons over there. A lot of people got a lot of feedback from people about what we're doing and the things that they like about it, and things like that. And there was also a pitch contest, which we won. So that's all good feedback for what we're doing. Yeah, I can't wait to go back. But right now, in the middle of kind of figuring things out. I do have a vacation at the end of August, so we'll have to skip another week, or maybe have Paul do that week instead of me, or something like that. But now that we're back, we're going to be doing a lot more things on the channel. For example, I would really like to kind of focus on doing, like, splitting the channel into the high level and low level things, because I feel like the low level things are kind of the things I kind of like working with both high level and low level things. And what we're trying to achieve here is definitely something that has both high level and low level components. So yeah, we're just gonna have to. I think it'll be good to split it up into two. So haven't decided on the date yet, but I'll announce later on when we start the low level stream. I think for the first low level thing, we're going to be implementing Llama on the vector engine and messing around with that, or possibly kind of there's so many things to do, right? In terms of like the vector database, or the LLMs, because one of our goals is to give people the ability to have local LLMs and things like that. So all that stuff is going to be, it's the low level stuff we're going to do. So we'll have a separate stream for that. And on the stream here, which I'm not sure if we're going to do it at the same time, like the timing of this stream in particular is a kind of really bad time for the US, right? If you think about it, it is currently like 4 or 5 a.m. In San Francisco right now. It's 10 a.m. and I think it's 10 a.m. in the East Coast, and therefore 6 a.m. or something like that in San Francisco. It's a little too early. Nobody's like kind of waking up and watching it. And I think having the streams be in different time zones might make sense. So I think for the low level stream, I'll have it either be on this time so that it's like a good time for Europe, and therefore a good time for Paul. And together we can work on low level things. And then for the high level things, I'll probably do it in the mornings, Japan time, maybe on a Thursday or something like that, or Friday, just to kind of see things. So we'll be working on that. So you can expect more things coming out. Also, we have plans to make a lot of tutorials and kind of restart a lot of the Twitter marketing things, showing the demos of things working. One of the interesting things about San Francisco is like all the people doing different things with agents, and they all congregate on the 2 or 3 use cases that actually work. And then the ones that don't actually work, it's kind of surprising to see how they're all faking it. I mean, it's kind of harsh, right? But, like for me, I think an agent, in the release notes for an agent, like added support for starbucks.com. That's not the way to do it, right? Like yeah, you can do it that way, but you really shouldn't be doing it that way. If you have to hard code how to order a coffee in starbucks.com, then you don't have something that's generic enough to be genuinely useful. Nobody needs an agent to buy them Starbucks, right? Like maybe somebody needs it. I don't know. I can see it being sometimes useful. Like if you could just go, "Hey Siri, buy me a coffee," or something like that. I guess that can be kind of useful. But what we're aiming for here is to get work done, and a lot of the time that work is, it's not something that's public, right? So we can't add support for everything under the sun, right? So we have to make a framework that's generic enough to figure things out. And one of the things I kind of like learned, even though we did win, second place in hackathon for kind of integrating Multion with Xpress AI, it doesn't really, like what it was able to do essentially was, Multion would have its agent that could figure out something on the screen and then give you the result as a string, usually in a single sentence. And then I can take that single sentence and then put it in a spreadsheet or put it in a Word document or you do something else from that. And that's like super limiting. It is, that's, the use cases in which that is enough are very, very small. I think what we really need is an agent that can work in a workbook, right? Like it can look at different cells, figure out what it needs to do, plan, and then execute, like a complex thing. Whereas what we have right now, is the agent will make essentially a program that does whatever it was you asked it to do, and that's it, right? Like that's what it's going to do. And I don't think that's probably not, it's not good enough, right? It's not good enough for real work. When we're talking to people who have use cases for Xpress AI, they're like saying, well, I'm going to get emails, and in the email is a PDF document. In that PDF document, there's like a SOW ID or a reference that corresponds to something in the budget. So there's an ID in the budget spreadsheet. And so we need an agent that can, one, find whatever that number is, right? Whatever looks the part, right? Whether that's going to be, even if it's like in a table and says reference ID or something like that, or order ID, that part, it's doable. It's actually kind of really difficult with current things, but it's something that I see as something that's kind of doable. But then having the agent go to the spreadsheets and look up this stuff and even know that it's supposed to do that, that's like an open question. Like nothing that exists right now has the ability to do that, which is why on Twitter I was kind of mentioning that there's an onboarding process that agents are going to need. And the thought behind that is that, let's say I do have this spreadsheet that has a bunch of orders, and that's the budget, and I'm getting these invoices, and the invoices have something in there. Well, the only way it's going to know that, the only way the agent is going to know that it has to look in that is if I tell it with explicit detail, right, that the order numbers are in this column and that kind of thing. But I don't think people want to go into that kind of detail. What I think people want to do is more like, say, in the budget spreadsheet, find the order number, and then if they match, then put it into, the receivables spreadsheet or something like that. So, lots of stuff to do. And I wanted to get started on, like version 2 of agents. And the idea there is I want to make a new type of framework that combines the abilities of the Hugging Face agent, which is pretty good, and the kind of planning capabilities of Baby AGI, along with more of the coding things of AutoGPT. And one of the things that I think is kind of missing in those is that they are not able to get the right experiences. And that is going to be pretty important, I think, that an agent, when it's tasked to do something, I want it to be able to recall the last time it did it, or when it failed, I want it to recall the last time it failed doing something similar. And then have the LLMs build on top of that. And then the other thing that I think we need is the agent will need to be able to create predictors of things as it's going about its work. And also collect experiences that we can use for fine-tuning. So they're like I have it in my head, there's all these things that we kind of need to do. A lot of them are inspired by the brain and the things that the brain has a region for speech or language in general. And then there's another region of the brain that kind of filters that language. And if you have damage to that second region of the brain, you have stutters or kind of speech impediments, right? So like the act of speaking and language are kind of different. Unfortunately, LLMs, they don't have that difference, right? Like they just say things. But if if you know LLMs, you kind of have to give them a repeating penalty and things like that, so that they don't say the same thing over and over again. Um, and Yeah, that's just like, there's some kind of parallels between the language center of the brain and language models. And I think that's an important part of the reasoning capabilities of humans, right? The idea that we can reason because we have language. Um, but reasoning is not everything, right? Like because we live in this world, um, we can predict the movements of objects, right? Like pretty soon after we're born, we discover that things fall, right? And that, things kind of move when you hit them. And, square pegs don't fit in round holes, those kind of things. And those things I don't think are necessarily language driven, because you can learn all those things before you have acquired language. But there is definitely a lot of things about reasoning that I think you do acquire through language. And I think the language models today are able to acquire those things, but they don't necessarily have um, the same kind of predictive power that we do in the general sense. So we do need to add that kind of capability. So I'm thinking, well, how do we kind of create the neocortex of the brain, the grid cells of the brain for things? How do we implement the memory, right? Like the cerebellum is, I think, where most of the memory is. We do have the ability to store vectors in a vector database. So is that sufficient? I'm not really sure. But if we don't have all of those things, I don't think we can expect that we'll have something that's generally capable. Like forget about generally intelligent, more like generally capable of doing work and figuring things out. Now I think a dog is capable of doing work, right? Like you can train a dog to find narcotics or hunt or things like that. So a dog is intelligent enough to be useful, and that's what I'm really aiming for. So I'm going to start with this stream, kind of like implementing these pieces and see how far we get, and see if we can get a project going, like a new GPT thing. I really don't like the term AGI, right? So I don't want to call it the AGI framework, but for now, that's going to be what we'll call it. So yeah, I guess let's get started on that kind of stuff. So let me start the screen sharing. We'll start here. Let me see if I can set my headphones to monitor, because they sound really weird. One sec. Okay, so I think I can monitor myself now, which is a little bit better than what I had before. Let me turn off this thing. Okay. Is that okay? That sounds a little bit better. So, welcome to my power dashboard. So, I've been like kind of, for some reason, obsessed with the power of this laptop, mainly when it comes to LLMs. So, just to give you an interesting kind of look, right now. So right now we're like sucking up 78 watts of power, 80 watts of power just to do the streaming. And If I were to go here and then do Llama CPP, for example. Oh, I totally forgot about that. Message still streaming. Okay, there we go. Well, the stream has started, so that's the way it is. Anyway, so for example, if I do main and some samples here, I think the interesting one is the one about languages. A language tutor. So if I start that, so this is using the CPU, and this thing will go up to like 110 watts, and that's pretty amazing. So yeah, and the interesting thing about my laptop in particular is that the CPU is a little bit faster than the GPU. So that's why I've been like looking at it because I kind of need to know if it's charging the battery or not. Once you start running this thing a lot, it can drain the battery quite often. One sec. Okay, I'm back. But anyway, Llama 2 is interestingly good, I think. Maybe not. It's not the best thing in the world, but you know, it's not too bad. So for French, it's like okay. The problem is if I were to ask it for Chinese phrases or Mandarin phrases, yeah, it's weird. I mean, in general, it's okay, but it sometimes comes up with it puts like English words and things. And I'm pretty sure that there's other ways to say those words than mixing English to say like what was it? Can I stay in the hotel tonight or something like that? You know, some kind of weird words. But you know, it's kind of cool that it works, and surprising how much watts this thing can draw. Because if you're just on the battery, it can't really pull as much as it needs from just the battery. And if you're on the charger, pretty sure the Apple one is 96 watts or something like that, the one that it came with, and this can draw more than that. So if you have that kind of like 90 something watt charger and the battery, it can go up quite a bit. I don't even have turbo boost turned on, so if I turn that on, you can see it go away. For me, that's been really interesting. Yeah, one of these I think will often have that. But anyway, yeah, 130 watts. That's crazy. Hopefully, you guys can still hear me, which would be amazing. But yeah, anyway. So let's start circuits. I get started. So I'm not really sure if I want to make a like a general framework in circuits per se. You could make it a Python thing that at the end has a very high level interface in circuits. So, might do that. Yeah, let me do that. Let me start with just a Python project. We'll check out the new AI features of PyCharm, I guess. I think I should have access to that. I've been a very good customer. There you go. XAI agent framework. Set this up. It is very much empty. With me playing around with Ray. So Ray is an interesting thing to use. Keep it at that. Let's give it a second to index the things. That's very interesting. Plugins. There's AI assistant, right? So let's get that started. I did this like yesterday, and I also earlier today looked into the toolbox to get the updates. I usually update all my tools on the first of the month, so that's why you have to wait for this to finish doing whatever it's doing. Okay, big data tools. I mean, I don't really need big data tools right now. We have this AI assistant. Something apparently. Get rid of that and make this nice and big. And yeah, so we've been playing around a lot with actors, and Ray has this workflow class, and it has this virtual actor, which I really like. I mean, I like virtual actors in general, but it's not here anymore. So whatever book that I was reading kind of doesn't have the updated thing, or maybe I need to pip install something. I'm not sure. But I really like the idea of having a virtual actor for things. But anyway, so let's get to the basic stuff. Okay, so we have the sparkles. So hopefully sparkles will be interesting for us. I think that's all the plugins we need to be updated. We give that one more check just to make sure. Just to make sure we don't have any more interruptions. Okay, cool. So the agent framework. So the main thing with the agent framework would be we want to kind of model the various regions of the brain. And there's a few. You can look at the functional regions of the brain, which is just guesses. Like nobody really knows. But we can, for example, if we go in here and look at this picture, there's the temporal lobe. This idea of time is kind of interesting, important. 5 should be hearing, right, which is right next to the ear, so that makes a lot of sense. And 11 is Wernickel's area, which is this area around the hearing, right? And that's where language comes from. And then here we have sensory. 10 is somatosensory. 1 is the visual area, right? So it's kind of like our eyes go all the way to the back. And an interesting thing that, as far as I understand, even though the brain is like this big kind of thing, there's like a bunch of insides. The neurons are just on the surface, right? So there's like 6 layers on the surface, and that's all pretty much everything. They're all connected from the surface, not inside. There's no connections inside the brain, although there is connections between the left and right hemispheres. So those are connected, and they're an interesting kind of information bottleneck. And if you remember, there's like last week or something, a paper about how people were able to beat BERT with just gzip. And for me, it's weird because I thought, using compression was common knowledge. I mean, I can't remember where I heard that, but I thought it was a common knowledge thing. So I thought it was so weird that people were kind of making noise about it. But anyway, like information theoretically, right? Neural networks, they, because they have a bottleneck, they need to compress. And by compressing, you have to make more kind of representations. And then that is really where a lot of the power of neural networks come from, even in transformers, because you are you have that softmax at the end. Your information needs to go through that kind of softmax. So there is a compression. Compression is kind of like one of the fundamental things about how these things work. In general, and I'm not sure if we're going to have to do this in the agent framework, but it could be that we need to have 2, right? Now, of course, I think you can have a perfectly functional human without the 2 sides of the brain. But in general, I think there's problems, right? Like there are some small problems when you don't have the 2 sides of the brain working. And interestingly enough, when it comes to humans, our left-hand side and our right-hand side are controlled by the different sides of the brain. So it's like interesting. In order to function in the world, these 2 sides need to essentially predict what the other one is going to do and respond accordingly. And that'll be a part of its of how it works. Right? Like it's like a big part of how a brain works. So I'm not sure if we need to do that per se, but this idea of having one side predict what the other side is doing is something I kind of want to have in the framework. And I'm not sure it makes sense to have a single LLM doing that. So we might have like 2 LLMs working together. Not 100% sure about that. But anyway, so we have our language region, right? So that's the 11. And then the frontal lobe and the cerebral cortex. The frontal lobe is the main one for concentration and planning and things like that, right? So for me, what's interesting is that that's not related to the language area. And so I'm not 100% certain that the baby AGI style of, asking the LLM to make a task list and stuff like that is really appropriate. I mean, it kind of works. It's not terrible. Sometimes it's not the best. But essentially, when you think about it, like baby AGI is hard coding the frontal lobe. It's like a hard coded single frontal lobe thing where we need to generate a task list. And then from the task list, we've got to prioritize the task list. So, it's kind of like instead of having an independent network functioning as the frontal lobe, it's a hard coded kind of thing. And then 3. So in terms of our agents, I don't think, maybe like something like 3 might be. So if it's going to be interacting with the browser, right, something like that could be, a thing. 4 is muscles of speech, and this is the area if you have damage to this area, stuttering or language impediments happen, even though you're perfectly capable of, if you have no issues on this lobe, then you have no issues with your language, and usually you can write just fine, but you can't speak if you have, or you can't speak very well if you have damage here. And then the cerebellum, which is the, it's like one of the oldest parts of the brain. And the interesting thing is this controls a lot of kind of memories things, I think. If I'm not mistaken, I could be wrong. Let me see what it says here. So emotions are in the 6th area, which is interesting because it's like you can think of the brain as like the evolution. It started from the cerebellum and then kind of grew. It grows outwards in layers. And so once there was the cerebellum, the next thing to really grow is like the emotion centers. Now, luckily for us, I think emotions and language are very tied together. And from my understanding, from like working with these language models, they're able to maybe not necessarily have emotions, but they can they can like work with emotions just fine. So that's okay. And let's see what else. Yeah, the main things I think that I think are missing from agents today, if we want to make software kind of autonomous agents that can help with work. I don't think we need a memory area, which I thought the cerebellum was one of the places where we store most of our memories in general, if I'm not mistaken. Could be wrong. I'm not a neuroscientist. I just play one on TV, essentially. But anyway, so we need that, which is something that's kind of missing. Language models form this area, and I think that's fine. The ability to kind of like filter what comes out of here is really the main point of 4, I think. Broca's area. So I kind of feel like we need to, yeah, it could be wrong. Like it's more like for speaking, right? But I do feel when you think, right, you might think of a lot of things, right? When you're writing an essay, you kind of come up with many different sentences, and it's like, no, that's wrong. No, that's wrong. No, that's wrong. That kind of critic is important. And essentially, the current thinking is that stuff is happening in the frontal lobe, right? So like the language center communicates to the frontal lobe, and the frontal lobe is kind of thinking of things. But weirdly enough, consciousness itself is way deep inside. I think it's around here. As in, if you mess with some of these regions with anesthetics, that's where the person kind of loses consciousness, right? So even though it kind of might seem like we live in here, we definitely don't live in here. Like a person, the consciousness of the person is more like in here somewhere, and these things all kind of work together to feed that. So yeah, really interesting. Anyway, so I think we need some things, right? Maybe let's start with a README. I think a README might be a good way to like introduce it. This is a brain-inspired framework for creating agents. I'm not sure I kind of like the term agents. I have no better one at the moment. Kind of think of agents as being like collaborative. Anyway, the major brain regions. I'm going to be more scientific here. We're going to call it the Wernicke's area. Right. And this is handled by LLMs, right? Then the speech production, I'm not sure if it's going to be handled by LLMs, but yeah, whatever. Okay, and then this will be handled by vector search. Emotions. That's an interesting one. I'm not sure if LLMs are the right way to do this, but it can kind of make sense. The LLMs are able to kind of express emotions, or you can say do something sad, do something happy. So that could be a thing. But I think it's more like we probably want a self, so like a network that kind of predicts the appropriate emotion based off of things. I'm not really sure that emotions are really necessary for work, so we might not work on this at all. It's probably best if we don't. Motor control we don't need, so we need frontal lobe. And the frontal lobe like the outputs of that are so crazy. Or maybe they're not. Like they could be pretty, maybe they're really simple. I don't know. But it seems to me like planning and that kind of stuff is kind of complex. We don't really have a data set for that, so I'm not really sure how to go about that at the moment. don't really need sensories. At least I don't think the sensory systems or the motor systems contribute necessarily to intelligence. I mean, they might, but probably not. Like not that much. They're more like outputs, right? Then we need temporal lobe. And this is prompt history. So essentially, the temporal lobe is a working memory, right? So like somebody gets hit in the head on the side, really, really bad. They can lose the ability to have short-term memory at all, which makes for some good movies, and otherwise kind of really sucks. But that's part of it. But essentially, this will be for the short term. Now, moving things from a short-term long memory to the long-term memory is something that I think will have to be done through training, right? Like models need to save this short-term memory things or commit short-term memory things to long-term memory in some way. And right now, my thinking of that is if we can store the experiences of an agent, then later on we can build some kind of long-term, like we can build it into the weights of the LLMs or maybe the frontal lobe, so that it can kind of when you think of long-term memory things, they are they're things you can look up, right? So perhaps it's more something that should go into a vector search database, something where you can have, there's some state, you can find exactly what you want from that. But we humans need to learn, like actively repeat things. When we repeat things enough, it becomes important enough to save in our long-term memory. And when we're good at that, it is easy for us to kind of recall it. And we can recall it very precisely. And for agents, I do think this is pretty important because, if you give it a job and it fails many times to do the job and then finally it does it right, you don't want it. You want it to like learn from that experience, right? So like next time you tell it to do the thing, it gets it right, the first try or after one or two tries instead of after like 3 hours every single time, which is the current state of things, right? Like the reason why I'm heading in here is because right now, if you tell it to do something and it fails 90% of the time, like in the other live streams, you've seen baby AGI essentially fail for 15 minutes or 20 minutes before it actually gets it right. And then I have to babysit it, and that's not useful. And once it is successful, I want it to remember how it did that, right? So we need to have this kind of like long-term memory committing thing happening somewhere. So Yeah, so we have 6 things more or less that we need to do. 5 or 6. Again, I'm not really sure emotions are absolutely necessary to do work, but I do think they are important for intelligence, or at least our perception of intelligence. So let's go to the different regions. And it's also kind of funny how circuits is used in the brain project, and we're here trying to make a virtual brain, and they're trying to make a virtual brain, but for very different reasons. It's kind of, the irony there doesn't escape me. So yeah, so we're gonna need like classes. Now I don't think naming them like Wernickel's area and Broca's area and hippocampus is useful. So I think we'll give them simpler names. So we'll want the language. So language. Generator. And for Broca's area, I don't think we necessarily need this area per se. I think, like this area, and there's no real reason why we have these two. The cerebral cortex does muscle things, right? Eye movement, right? And then this one's mouth movement. So essentially, like our face muscles are controlled here. And then other voluntary muscles are controlled here. And then inputs are here. And 10 is an interesting one. The association area might be something we might need. But like this is our outputs. So I don't really think we need Broca's area. Let's get rid of that. Nick. I have a memory something, right? So memory. Motion state. Planner. You want to have a long-term memory and a short-term memory. State planner. Like those are the main things, like in the domain that I'm thinking of. Now, one other thing I know is, or not really sure I know it, but one thing I kind of remember from what was his name? It was the guy who created Palm Pilot. Jeff Hawkins. Jeff Hawkins has a book on intelligence, which was a good book, I think. And he and his company has mainly been studying the brain to do and recreate that in software. And they unfortunately haven't really gotten anything really useful out of it. But yeah, so pyramidal cells are something that he talks about there. The fact that there are 6 layers is something that to this day I think is crazy. You know, if the brain was a neural network, it would just be 6 layers. 6 layers deep. It's a very wide, not a very deep network. And yeah, like essentially a lot of the depth that I think we do need in normal neural networks are things that we need to, or that the brain needs to use cross talk and interference and prediction to get up, which is really interesting. Yeah, like these things that fire before, you know, like a brain needs to essentially predict the future. Like it, there's that experiment where if you have like this mirror and then you have like a fake hand and then you have the person's real hand and you brush them both, like use a brush to stroke both of the hands at the same time, even though the person can, you know, like knows that that's a fake arm. If you do things that, you know, at a primal level make it go like, okay, that's my arm, right? Like you start to feel the sensations in the hand, and then they stab it with a knife or something like that. You will feel pain, right? It's a fake pain. It's a predicted pain based off of what you're seeing. So yeah, there's definitely a lot of prediction happening, and that's what I think is kind of missing from things. We need predictions. Like I'm not sure what the inputs and outputs of it would be right now, but we need something that can that we're like constantly fitting on. You know, like we fit on that, and then we're using those outputs. Mm. And yeah, so this book is really good. I wish I still had. I had this in paper. I just can't find it right now. But anyway, let's also. Maybe not future predictor, but like outcome predictor or something like that. And then if we were to like the brain is not necessarily a simple pipeline, so it's not a matter of like planner input like sends output to this, output to that. Hmm. predictor. But I think this outcome predictor, like having a critic type of thing, is important to have things work. Yeah, right now, if we remember how baby AGI works, there's an executor agent, and that's the other thing. So, like, I would like to say agent here, long-term memory agent, right, and then emotion state agent. But then, what do you call the aggregate of these things? That's not an agent, because if these things are agents, then what is that? And then, an agent is something that needs to have an agent from the reinforcement learning way term. It needs to have agency, right? That's why they call it agent. It needs to be able to interact with the environment and receive stimuli from that environment. These agents, if I called this thing an agent, that's just dumb because it doesn't have any of those things. And then in terms of the outcome predictor, I was kind of saying that this has to be a neural network, but it doesn't necessarily have to be a neural network because LLMs, they're few shot learners of sorts. So it's possible that we can leverage LLMs as the outcome predictor. Anyway, you can kind of see that the outcome predictor's outputs go to the planner, right? And then the planner creates some sort of output to the language generator. I don't like the name language generator. So that was my train was early on. Let's see. I wish I didn't live next to a train. Maybe to keep it in line with baby AGI, we can call this the executor. And, like in that sense, in the GPT agent toolkit, we had the tool executor, which you can argue that is kind of cortex of sorts. Cortex. What? Let me check the AutoGPT. And Hugging. We learn about these things. So if I think I remember correctly, there is a critic. Yes, there's a thought, reasoning, plan, critic, next action. And that's how it works. And it gets stuck. Very often. Yeah, and this guy kind of has the problem. Yeah, he like nails it, right? Like just spend loops 20, 30 times without solving it. And that will totally happen. Yeah, I think this is more or less what it does. Has some commands. You can do some stuff. So you have executive memory. The thing with AutoGPT is like this is like a one thing, right? And when you think about it, in terms of like the brain, these kind of match, right, in various ways. So the text is the language processor, the reasoning, get a question, plan, right? That's the executive system. The criticism is kind of what Braca's area is doing, but not really. And then there's the speak, and you know that is what Braca's area is doing. That would be where you're talking about things. And if it is asking, so like one thing about how LLM works, which I think is something that a lot of people forget, is it doesn't have the ability to kind of see what it's saying, right? The language model outputs a probability distribution for every word. and it doesn't really get to see what it picks. The beam search or something down the stream will pick something and then we'll put it in there. So it gets the ability to see that as it's being generated. But I don't think that, I think we're giving these things a little bit too much credit about what they can do inside of some of their layers, right? Instead, if you had the text and then you put that into the next prompt, and then you have that do the reasoning, and then you put that into the next prompt, and then you have the plan, right? So if those are 3 different LLM calls, now things make a lot more sense from the LLM perspective. It can see the entire reasoning, not just one of the words. And it can then make some more intelligent decisions based off of that. So I'm like, in my framework, that's how it's going to work. We're going to like let the LLM get its outputs as inputs, not kind of assume that it can, reason. Like this reasoning here, it's just fake reasoning. It's not. Yeah, I mean, you can argue whether or not LLMs have real reasoning or not. But it's like it's sampled, and it can get killed by the sampler, essentially. But by having it be the input, then it has a lot more of a chance to spike itself, right? Like there's probability distribution, and the word that's supposed to be needs to have a high probability. If things are, being processed one character at a time without the ability to like look back, I have the feeling it's like going to be a very smooth, it's like a more smooth probability curve of things that are possible from given that input. But if you give it a separate kind of thoughts by itself, then you're going to have a little bit more spike. So that's the plan there. So let's call this considering calling it thinker, but that's a dumb name. You need a better name for this one. Yeah, we need a better name for that one. That one's going to be pretty hard. Yeah, then we have our cortex, which would be so we have, it's like the idea. Maybe let's call it a reasoner, right? So we have reasoner and then a critic. I think it doesn't make a lot of sense to just have a critic. So at least in here, right? Like after the criticism, then there's, speak, right? So we need to have something that, generates some language, critic that internally uses the current state of the world to then work with that information. Then we want to output that into the planner and then the executor. Yeah, I guess that makes sense. Like from a normal perspective. So you have a reasoner, a critic, a planner, and then executor. And then in each one of these, we have, that long-term memory. Hmm. Question about how long-term memory works in here. I have an idea of, if you're using a model like RWKV, its hidden state is a type of long-term memory of sorts, but it's not exact, like it's super fuzzy. So I'm not sure it can be relied on from the same state. And I think each one of these has their own short-term memory. Now, where the motion state really comes in here, I'm not really sure. So let's get rid of it. Do amygdala adjust for emotions? Let's look at it. Comprise approximately 13 nuclei. Isn't that amazing? Like when you think about it, just 13. It's like similar to like, number of layers being 6. Right? That's six. That's it, right? Six layers. That's all you need. And here there's 13 nuclei, and that's pretty much it. So it does have emotion. Yeah, it modulates memory. That's kind of a good point when it comes to like when you get scared of something, or you can experience pain and you fall over, for example, when you're a little kid. And that was terrible. And because it was terrible, you remember it. Right? And you remember it so that it doesn't happen again. I think the critic is an outcome predictor. Right? If we give the prompt, if we tell the prompt that its goal is to predict the outcome, right? And the planner and the executor, so they're all fed information from the long-term memory. I guess the amygdala does. Is it involved in the so something in the brain kind of regulates memories and then gives you access to those memories as you're thinking of something. And in here, right, just looking up the vectors is not good enough, I think. There's not necessarily a guarantee that those vectors are relevant. And I think we also have memories, like we remember things that aren't necessarily relevant all the time, but we can ignore them. We have no problem ignoring like irrelevant memories, right? So between these things, why did that change so crazy? Is the hippocampus 1 sec? Yeah, that's where we store the memories. In theory. Yeah, that would be where we store the memories. But is it just the same thing, right? Like, would the critic that, so we have a reasoner and yeah, I guess well, let's do it this way. So the amygdala, memory, for this word I'm looking for, modulator. So now I do think we need something like this to automate the work. Now, it's not. I know it is a emotion thing in general, but I'm currently thinking about when you're happy, you have more happy memories, right? Like your state, your self emotional state changes the things that you recall, right? So this amygdala thing needs to determine what long-term memory to recall on the current state or situation or something like that. I think that's perfectly fine. So in that case, the amygdala is kind of an agent of sorts. And then the reasoning, why is the reasoner have its own short-term memory? That is also kind of brain inspired. You'll notice the language center. I always forget. Wernicke's area, or Wernicke's, yeah, Wernicke's area is kind of connected to the temporal lobe in essence. So, yeah, main idea there is that the short-term memory is the prompts, like the previous prompts. And that forms, I'm not sure if we should kind of ask the LLM to have a notepad of stuff. It kind of is okay at getting notes, right? So like it could be like the scratch pad, and it's just something that we put into the prompts, and then after we've done something, we then ask the LLM to summarize this into short-term memory. We can then do that. Yeah, that's it. It's something you inject into the prompt history. Yeah, this is what I think this is more or less what we want. Something that has many things that are not in Baby AGI. Let me check the list, Baby AGI. They have been doing all sorts of stuff. There's a new one coming out soon. But I think this is more or less the same, right? The API. This thing has the task list, and then we have the different tools, stuff that I did many months ago. We have our task creation agent. And what else do we have? Let me submit the tasks and the let's click up here. And we have execute task. Yeah. The latest Baby AGI is less it's more focused, right? Like it's kind of more focused on what um, they really want to do, which is kind of like having a research bot of sorts. But I'm thinking more of something that like does multi-phase kind of tasks. Is there another word for amygdala? Yeah, so it's the memory, decision making, and emotional response. Another thing to think of is like, do these three things really deserve to be in the same location, right? And there's only 13 things. Um, we really don't know. Like for us, we need to keep in mind we do not know what is necessary for intelligence. We can only know that the human brain and many other animal brains are sufficient for intelligence. So, with that in mind, you know, we look at the different things that we need to implement, and then we implement those. And then once those are implemented, we can then use that learning to figure out, what are the necessary things we can. If we can get rid of something, um, then we should. Uh, you know, airplanes don't flap their wings, and that works fine. And then this connected loop. If you like my ASCII art skills, long time to become an ASCII art master. And we do that. That's 5, right? Mm-hmm. Line those up. And then a nice little bar here. There you go. Hopefully this makes sense. Now that I see it this way, I kind of feel like, oh, this is kind of easy enough to be a circuits diagram anyway. Hmm. The main thing that's missing is that the short-term memory thing. Then the other thing that I think is missing is the ability to like train models. Hmm. But I'm not 100% sure we need that. Because again, LLMs are kind of like few shot learners. So as long as we have the necessary things in the short-term memory, then it will be able to do what needs to be done. And it will be able to predict the outcome based off of the current state. So where to start? Let's start with this STM thing. So what do we call this instead of agents? I want to call this something except an agent. I don't think I need an STM thing there, but like, let's say we have a reason. I want these things to inherit from things inherit from it's like a brain region, but I don't want to call it a region or something like that. Brains are organized in that our brains are not organized in those things. We put those names in there. It's gonna be really good. Okay, so let's call these reasoners. Because we have reasoner. We have the we have the reasoner. We have the critic. We could call him an actor. Let's get the rest of it. And we have the planner, right? And then finally, we have the executor. These things are, what should they be called? I'd also call them components, but that's super generic, and I don't think it's very helpful. These things contain, so because I want to, they are they have a short-term memory, right? Like, so there's a history. It's some list of string type of deal. And then that's their short-term memory. So I guess we'll call it short-term memory. Call it STM. And what do we call this? It is it's not an agent. And I don't want to call it actor because like in programming, actors have like mailboxes and stuff like that. This is not. It's not an actor. This is module. I need to think of something that's a little bit more descriptive and less whatever. Let's just call it a module for now. Right, and then the module should start off with the empty STM. And then they have a kind of like abstract call. Call module. Execute. It's just ask. It's an LLM call essentially is what this should be. So the module needs to have. Let's call it call for now. That's that. Okay, so modules are things with STMs, which can be called. And the reasoner, I guess they should have like a prompt. Maybe let's call it system prompt. Right, the STM, which is a list of things. And that's pretty much it. I think Baby Asia has a couple of other things. But that reminds me, I need to look at this Hugging Face agent too, because this one's pretty good. The chat prompt template is okay. Let me see if I can find the source, and then should have a chat prompt template.txt in here somewhere. So mine looks like it's not very useful. But anyway, the way that the Hugging Face agent works is that it essentially generates a script. And that is pretty good. Generates scripts using PyTorch. And in essence, a lot of the things I'm thinking about when it comes to the outcome predictor, like right now I'm thinking, okay, let's just use an LLM and see how well it goes. I think ideally it should be a little bit more than that. I have the feeling that our brains probably do this naturally. But right now we're just going to use an LLM for it. Instead of call, let's call it run. I think I want to stay away from it. We run the thing. Now the reasoner The prompt is so we have the reason. Let's go back here. So baby AGI has the task list. I think the task list is generally a good thing. Even as a human, I typically make myself a task list. It could be that when you ask it to do something, it will naturally make a list of things to do. Save that list of things into the short-term memory by itself. And then execute those one by one. And in Baby AGI, that process is hard-coded. We may want to hard-code that here. Maybe that is the planner. The planner outputs the list of tasks. Then what does the executor do? The executor or do we need to have the planner earlier in the cycle? It's a really good question. Yeah, I do think I'm kind of leaning on having the planner earlier in the cycle. Because it should be after the executor, right? Like if the goal is to do something that requires us to write some Python and execute that, we don't know the outcome if we run the planner before we execute that code. So that should be here, and this reasoner should be here. Yeah, I think that makes sense. Now, let's start with the task creation prompt. Maybe not here. Just yank it from the agent toolkit, which now has 241 stars. Pretty cool. And all very much natural stars. Now, this critic prompt does not work very well. Let's put these things. Let's take these and put them in here. Okay. And then instead of task creator. This is the planner prompt. Right, prompt. And we have a reasoner prompt. Let's call this one the reasoner prompt. And it's the executor prompt. And let's put this in the right order. So we have the reasoner, critic, the executor. Okay. Now, if we think of it that way, there's not that much of a difference from Baby HEI, except the short-term memory, and then later on the long-term memory. But I guess that does make sense. Like the general loop makes sense. So anyway, so let's fix up these prompts. We won't know how they're going to work until we actually do them. That you are a planning AI that creates tasks. Pass the butter. Complete. The objective is the last completed task as the result. Yeah. I think yeah, like that's the result of the executor, right? So the executor does the thing, the results of that go to the planner, and then the planner figures out the next step. So that makes sense. The last completed task has the result. Now, the results, this is another part where Baby HEI gets hung up a lot, because if you're just using tools, this result can be quite big. And not necessarily relevant, right? Like that's kind of the main issue. Okay. And it also has a short-term memory, which you got to deal with. Okay, so the idea with the short-term memory is that it's essentially just we're going to have a history of the previous calls to it, right? So it has access to all of them, and we have the prompt. So it will be like a conversation with a bunch of system messages, and then that's the idea. And the model is kind of free to use that as necessary. As it's short-term memory. So that'll be how that works. Okay. So the objective is that. objective. How do we put the objective here? The objective is also a weird thing, right? So let's say I want it to work in a spreadsheet, right? There's different things that it has to do, and I'm not 100% sure having the objective will always help, because if you've broken it down into tasks, you just want to do the task, right? You don't necessarily want it to deal with the objective. Now, this is the planner, so of course it's going to have the objective, I think. Okay, well, we can try that anyway. Then the last completed task. The last. That says the result. Last completed task. I think we can save some tokens by saying task. That. Add results. Do that. And does it need the incomplete tasks? It's something I'm kind of worried. I've been wondering about, because it could just generate the entire task list every time. And so having a task list means that if the status of things have changed sufficiently, you're beholden to the task list. So perhaps you're already on the page that you want to be on, but there's still tasks in the task list that aren't relevant to your current status. So I think we don't want tasks. And instead, the planner will generate a list of tasks. And in that sense, the baby deer AGI essentially takes that and then parallelizes it to the different executors. We could try to do that. Why not? Let's see. We have task list. How do we choose the next task? There was the prioritizer in Baby AGI. That's a good question. It's just the priority. Let's go back to the code. So it's an executor. There goes the planner. And the task. And the planner. And the reasoner has to come here. There's no point for the critic to criticize the plan. Um, yeah, we got to do that. Fix that real quick. So we have planner, reasoner, we have critic, outcome predictor. It tells me I'm on to something different there than just this critic business. Outcome predictor. That's like that thing is actually a powerful part, I think. But what I don't like about this is that it's kind of essentially baby AGI at a high level, even though the plans with the short-term memory and long-term memory make things a little bit different. Let's also make a default amygdala prompt. Searches for tasks. It's very objective. And the task is I'm gonna need a much crazier prompt. Okay. These are current objective, the last completed task, the result. I want to create tasks. Like, I do not like the hard-codedness of it, but at the same time, I'm thinking about how to make a UI for this kind of thing, knowing that these things output lists of tasks, and those task lists can be, visualized easily, right? Like that's a really big win. But it limits what it can do, right? Like it kind of stunts how it can work because it's always going to make a task list and then act on the task list. I just need to, and I think in general that's fine. But is there something that it could possibly do differently than just make a task list. Hmm. Task list. So that, things that it could be, I can kind of think of different advantages to not having hard-coded task list. But it would mean that the planner is able to activate the downstream things by itself. And I think that will make things a lot more complicated. But like, it is kind of important if you're like trying to storm a castle, that you're not just beholden to a task list. And I think in everyday work, it's kind of going to be the same thing. Hmm. Task list. Of course, some people also have like weighted task lists, dependency lists. We probably want it to do something along those lines. Could it make a plan to execute? I think it could. Hmm. Task list. So Hugging Face Agent doesn't make a task list. It makes a program that calls the different tools. And what I'm trying to think in my head, essentially, the Hugging Face Agent is pretty good at being something that is useful. And I think the planner could be just as useful. So essentially, the planner would output something which determines what will happen next. In terms of like which module to execute next. But that's part of the reason why we have the reasoner and things like that. And again, the UI is kind of important. We want to know what the agent is currently up to, what its plans are. One second, let me close the door. Okay. So having something more. It could create a task list, but and it gives it that, like, it gives itself its task list back, and then it has to pick the next task list, right? Next task first. Yeah, something like that. Okay, and then I want this to be a chat. So we have a role system. Content. Yeah, so I'm going to make this a chat. So originally, Baby AGI was not using OpenAI chat. It was using a completion model. It now uses the chat. Though I think in general, we feel like the completion was probably a little bit better. It has more entropy, essentially. Like ChatGPT wants to be like ChatGPT, which is kind of a problem. Anyway, what I want to do here is have some examples. Let me just double check. Yeah, role user content, whatever. So role system content, whatever. I think that should work. Then we need to think of some examples. But it's also really late. So I do think I will stop the stream here and we'll pick it up in the next one. Because now we have more or less the basics in place. And prompt tuning is like watching grass grow. It's not going to be fun. So, in general, I talked about what I wanted to do, which is kind of use the brain. We know that these things are part of the brain. Right? The brain needs to do a lot of translation from our thoughts into muscle movements, things like that. In this case, we're not necessarily doing that per se, so maybe we don't need it. But, in general, there's these things, and you translate them into these things and try to run a brain loop in the thing. That's the agent framework. Or it's like the foundation of the agent framework. One of the other things is when you deploy an agent in the Xpress AI platform, there's going to be a kind of difference between the receptionist and the worker agents. And that's also a thing that I have to include into the agent framework. Yeah, I think we'll just leave this here for now. I'll work on the prompts offline, and maybe next week we'll continue and we'll see where I've gotten in about a week. And then see how that goes. So anyway, it's 12:30 now. I think I will sign off for today, and I will see you guys in the next one. To know the date and time of that, follow us on Twitter. So my username is WMEddie, but you can also look at Xpress AI to find the next date for the next live stream. It will probably be a morning Japan time, evening San Francisco. Probably Thursday, maybe Friday. If you have an opinion, chime up. But yeah, I think we'll go for Thursday afternoon, like not after 6, but like before 6 kind of deal. Short live stream that's going to be a little bit more like this, right? Like this is the agent kind of light live stream compared to the high level one. And then next week on Tuesday, we'll be doing the low level things. Probably messing around with Llama and stuff like that. That's kind of cool. And also, we have not forgotten about RWKV. We have some ideas about what we can do there, especially regard with this. So we'll see. Once this is ready, I want to swap it out. We'll see how that works. But anyway, so that's all for today. And I'll see you guys next week. Talk later.